and I either can't do it at all, or it takes me like seconds so I can feel going by to respond to it. There are probably moments. Some of you are still pretty young and pretty fast all the time. Probably some of you have moments under stress and this kind of similar experiences. Yeah, and in fact, I do find not only, so these bottom slides here both this intra-individual variability, and again, you don't see in simple reaction time, it stays about the same up to about 50, and then it increases really quickly, and increases more at the later years. It's at higher levels for women than for men, as are some of the reaction time measures there. Although the means mostly overlap, although we're in the higher range. And here you've got some that are not overlapping. And with the choice reaction time, it's also a little bit curvilinear, but starting up faster, and then the women are even more separated from men on intra-individual variation. And increases in that. Now, another kind of thing that you could look for, they don't actually report it in their paper because they announce early on that what they're interested in is this within the person variability, is that you could also get inter-individual variability. So people could be more variable in later life than they are earlier in adulthood, in which case you'd want to know what characteristics of those individuals make them slower. In that case, we have several candidates in terms of clearly one of the earliest signs of most of the dementing disorders that are progressing is slowing down. Cardiovascular disorders of all sorts result in slower reaction time. Diabetes does. Subclinical levels of hypertension and high blood glucose levels have some effect on reaction time. And most of the medications that people take for all of these things also slow down your reaction time. So you can get pretty slow if you've got all these things going together. Another thing they point to, as I commented on in the PowerPoint slide, is that there's also a fair amount of variability in speed across tasks. You can also see differences in both levels and time course over age here. But as you go across different kinds of tasks, you get different kinds of age effects, both in terms of how extreme the slowing is in the later years, and also how correlated the slowing is with chronological age kind of tasks. It's true of a lot of the cognitive literature. What people expect to be even fairly small changes in what you're doing sometimes make fairly large differences. So any other questions, reactions? Yeah.
How would you view their results? Because there are so many confounding variables. And how would you value their results?
This study in particular, or just more general? The first thing I was inclined to say, there's a better way of saying this, is that people doing research at this level of psychological processing tend to assume a very high level of generalizability and universality of the results rather than necessarily showing it. And so, like, a lot of the kinds of confounds that you might identify and try to control in one way or another at more like social psych or sociology levels of research, people don't tend to pay as much attention to here. No, there are exceptions, and then there are people, so there are people who try to look at specific illness effects, or will try to remove from the data set people with certain kinds of illnesses, or if your focus is on the illness itself. So if you're interested in hypertension, or you're just interested in the effects of blood pressure on psychological processes, people actually can do research on that. But it's not common for people to do a lot more in these kind of studies than not use people who are in nursing homes, assume that people that can get to the study and participate in it are healthy and normally aging. And sometimes, as we saw like last week with the Stevens and also on sensory thresholds, you collect one or two intellectual measures to try to control, either to try to screen out dementia or to try to control for cognitive individual difference variables that you think might be important. Like people, it's fairly common right now because the whole executive functioning notion is sort of hot in cognitive psychology and neuroscience, that people will pick some measure of executive functioning as an individual difference variable. In studies that aren't focused only on speed of processing, people will sometimes get a speed measure as something to control to see how much of the effect of age on, say, attention or working memory is in fact due to speed. Usually their choice of measures is pretty simplistic, if not just odd. But yes, about speed. See if I can get us through the Anderson et al. Paper for a variety of reasons. Oh, by the way, the guy, for those of you that were at the colloquium, Liz mentioned in introducing our colloquium speaker today that he trained with Gus Crake, and this is another Gus Crake paper. He's been around for quite a while. So, there's a couple of reasons I like this paper and have hung on to it for a number of years. One is it has a nice review of the way, because it's got memory, it's got attention, it's got free recall, it's got cued recall, it's got recognition, it's got everything. And more conceptually, it addresses a question and comes up with a really different answer. That has been a theme throughout a lot of the cognitive aging literature for the last couple of decades or so. And two threads through cognitive aging that people have come back to pretty frequently are effort and intentionality, automaticity of processing. And on the effort side of things, generally what people have found in memory and quite a few other cognitive tasks is that the more effort a task requires, the worse older people tend to do at it. And so this actually leads to some, at least on the surface, sort of paradoxical findings, like if you tell older people that they're going to be tested on a prose passage before they read it, they do worse than if you don't tell them. So like implicit learning tends to be